Hi, I'm Amireza.
And I'm Tara Num, and we're here today to present our work on the relationship between extroversion and brain laterality. The nervous system has evolved to be lateralized, which means specific side of the brain is specialized for doing certain functions. The most complex form of laterality, we see it in the human brain. For example, language and some emotional processes are both structurally and functionally lateralized. There's also some evidence suggesting a relationship between extroversion, introversion, and brain laterality. For example, mixed-handed individuals are more likely to be introvert, while left-handed individuals are more likely to be extrovert. With regards to extroversion, there's also some structural data, which suggests that extroversion co-varies with the volume of medial orbifrontal cortex and is positively correlated with gray matter concentration in the left amygdala. Extroversion is also encoded within resting state functional connectivity between seat regions and the lateral paralimbic regions and dorsomedial prefrontal cortex. With this data in mind, we hypothesized that there might be a relationship between the extent of introvert or extrovert trait and the laterality of brain activity during language and social tasks. In order to test this hypothesis, we worked on the task fMRI data from the Human Connexome Project database with two tasks in mind. One language task, which consists of 4 blocks of story task, followed by 4 blocks of math task, and one social cognition task, which are some short video clips of objects moving either randomly or interacting with each other. The extroversion score was also measured as a factor from the NEO 5-factor inventory. There was some missing data as well, which were either individuals who did not finish the fMRI tasks or individuals who did not have a NEO extroversion score reported for them.
So in order to undertake this task of testing our hypothesis, first we defined laterality. And the laterality is difference of activation values of voxels across hemispheres. We can achieve this with just a simple subtraction, because in the pre-processing pipeline, these voxels are registered together. And we know that a voxel with a particular ID on one hemisphere is a counterpart of the voxel with the same ID on the other hemisphere. So we just subtract these two and get the difference in activation. We also needed a significance mask, which is based on brain activity during tasks that are language and social. To get this, we performed the right tail t-test, right tail because we wanted to test that activity is strictly greater than 0 and not just different from it. And we called the threshold at p-value of 0.05 and obtained the significant regions. Then we averaged the lateralities that we computed within these significant activity regions across voxels, right? So laterality is averaged out across voxels in these significantly active regions. What we are left with at the end is a single number which represents laterality per subject. To test our hypothesis, we calculated the Pearson correlation between the NEO scores and the laterality score that we just computed. We also compared highly introverted and highly extroverted subjects to get a sense of, to represent the differences on a map and show where these differences are more pronounced. So this is a histogram of our data regarding the extroversion score, and the subjects who are more than 1 standard deviation above mean are considered highly extrovert, and the other side subjects are considered highly introvert. These two categories were close in numbers, so we don't have any issues with the number part of the statistics. So this map here shows a t-test that tests if highly extrovert subjects show more laterality than introverted ones. And what we see here is the log of p-value of that t-test, which the threshold here is also 0.05, and we basically see nothing. For social task, we did the same procedure again. And of course, the activity filter, the significant activity regions are different here. But again, we don't see any significant differences. About the Pearson correlation, we see that it is not a big number, and the p-value is a big number. So, well, nothing. The scatter plot for language task, again, didn't show any significant correlation. And we can't identify any nonlinear relationship of interest. The same thing goes for social task. So these results are that we didn't find any meaningful relationship between the two factors. But of course, there's a saying that absence of evidence is not evidence of absence. But we can say in this data, in this particular study, on this data, with our particular method, we weren't able to spot a meaningful relationship. But this still can be important because
both laterality and introversion and extroversion are altered in many psychological disorders, such as schizophrenia. For instance, both cerebral asymmetry and also functional asymmetry are reduced in schizophrenia. And we can see that in, for example, dichotic listening studies, or see it as less language laterality in general. Schizophrenic individuals are also more likely to be introvert than to be extrovert. With these together, we believe that when we find a meaningful relationship between these factors, that might help us to get a better understanding of the underlying mechanisms of this complex disorder, and also help us to develop novel diagnostic tools. For example, when we have a healthy individual with schizophrenia background, and this individual starts to show more introvert traits, that might be a risk factor into developing more severe symptoms in the future.
So our team was me, Farbakhsh, Taghavi, that you know, Farzadkia, and we were probably supervised by Rafipoor from the University of Oxford and Dr. Rajimehr from the University of Cambridge. Thank you for your attention.